This first page is the title slide, introducing the topic HPLC for practicing scientists. It mentions that this is an intermediate-level training focusing on pharma analysis. The presenter is Michael Dong, Ph.D. This slide outlines the agenda, focusing on recent developments in HPLC columns. We'll cover hybrids, CSHs, charged surface hybrids, SPP, superficially porous particles, HILIC, hydrophilic interaction chromatography, SFC, supercritical fluid chromatography, chiral separations, and MMC, mixed mode chromatography. We'll explore what hybrids and CSHs are and why they're useful. Then we'll compare SPP and TPP, totally porous particles, explaining why SPP is often preferred. Finally, we'll discuss other column developments impacting pharma analysis, including HILIC, SFC, chiral separations, and MMC. This slide introduces hybrid particles, also known as silgel. These are made by incorporating RC bonds in the monomer, where R equals methyl. The slide shows the chemical structure of a hybrid particle. Xterra particle technology, 1999, is noted as one of the first commercial hybrid products, using monomer, tetraethoxylane. This slide shows a diagram from Waters Corporation. It explains that the methyl groups in Xterra replace half of the silanols, reducing silanophilic activity and enabling a higher pH usability range. We see a visual representation of an Xterra particle before and after bonding. This slide, with a diagram courtesy of Waters Corporation, illustrates the pH stability of Xterra packings. It shows a wider usable pH range of 1 to 12 at room temperatures. This slide, with a diagram courtesy of Waters Corporation, explains bridged ethyl hybrid BH silica. BH silica uses tetraethoxylane and bis, triethoxysilyl, ethane to improve pH and temperature stability, along with improved mechanical strength. It's designed for high-pressure operation in UHPLC, improving efficiency and peak shape. Brand names include Equity, Xbridge, and CSH. This slide discusses charged surface hybrid CSH technology. CSH provides good peak shape for basic analytes at low ionic strength mobile phases, such as 0.1% formic acid. The slide also mentions that in the 1980s, TA masking agent was used for drug analysis. This slide shows the selectivity of 3 CSH phases, C18, phenylhexyl, and pentafluorophenol. The slide cites a Waters Corporation application note on practical applications of CSH technology. It highlights orthogonal selectivity. This slide introduces superficially porous particles, SPP, with diagrams courtesy of Advanced Materials Technology, AMT. It asks what SPP is and why it's better. This slide explains that one of the most exciting innovations was the development of SPP. It is an improved particle morphology consisting of a porous layer with an inner solid silica core. SPP has 20 to 40% higher efficiency performance compared to totally porous particles, TPP, because of lower A and B Van Deemter term contributions to HETP. This slide compares HILIC chromatograms using TPP versus SPP in fast separations. It states that SPP is 20 to 40% more efficient due to a decrease in A and B Van Deemter terms. This slide discusses hydrophilic interaction chromatography, HILIC. HILIC is an alternative orthogonal approach to RPC, with a different retention mechanism particularly useful for polar compounds. It involves partitioning with a water layer adhering to the polar support. The slide outlines the pros and cons of HILIC, including its suitability for hydrophilic analytes, compatibility with ESIMS, and potential challenges like less predictable retention and longer equilibration times. This slide provides a comparative look at chromatograms of RPC versus HILIC. The HILIC method shows an orthogonal separation compared to RPC. This slide introduces supercritical fluid chromatography, SFC. SFC is particularly useful in purification and chiral separations. There's been a recent resurgence in SFC in pharmaceutical analysis due to improvements in columns and instrumentation. SFC is preferred in high-throughput purifications in drug discovery labs. This slide discusses chiral separation using polysaccharide columns. Chiral purity is a critical quality attribute in chiral drugs. This slide introduces mixed-mode chromatography, MMC, highlighting its ability to simultaneously determine positive and negative pharmaceutical counterions with CAD, charged aerosol detector. MMC offers a generic alternate approach to ion chromatography for determining counterions. This slide summarizes the key points and conclusions. It highlights the advantages of SPP over TPP, and the applications of HILIC, SFC, Chiral columns, and MMC. It also mentions hybrids and CSHs as innovative supports for stronger separation with less selenophilic activity and for separation of basic compounds with simple mobile phases. This slide encourages viewers to subscribe to the presenter's YouTube channel for more videos and to visit their website and LinkedIn page for more resources.